Hello everyone, my name is Hiren Patel, working as Assistant Professor in Mahatma Gandhi Institute of Technical Education and Research Center, NAVSARI. In our previous lecture, we have discussed about the basic VCR system and modification of that VCR systems. Now, in this video lecture, we are going to learn about compound VCR system. Till now, we have seen that in single VCR system, there are some modifications available, but there is no change in COP. So sometimes what happens, the vapor refrigerant is required to be delivered at very high pressure and single stage system provides low pressure. So in such cases, either we should compress the vapor refrigerant by employing a single stage compressor with a very high pressure ratio between the condenser and evaporator, or compress it in two or more compressor placed in series. So the compression carried out in two or more compressor is called compound or multi-stage compression. So in this video lecture, we are going to learn about the compound VCR system. In compound compression refrigeration system, the superheated vapor leaving the first compressor need to be cooled before enter to the second compressor. So such cooling is called intercooling. Okay. So there are some advantages of this compound systems, that the work done per kg of refrigerant is reduced in compound compression with intercooler. It improves the volumetric efficiency. The size of two cylinder may be adjusted to the volume available. It also reduces the leakage loss. It also gives more uniform torque and hence smaller size flywheel is needed. It also provides effective lubrication and it also reduces the cost of compressor. So these are the advantages of compound VCR system. So here in our syllabus we are having 7 different kind of compound system. The first one is two-stage compression with liquid intercooler. Second one is two-stage compression with water intercooler. Third one is two-stage compression with water intercooler, liquid subcooler and liquid flash chamber. Fourth one is two-stage compression with water intercooler, liquid subcooler and flash intercooler. Fifth one is three-stage compression with flash chamber, and sixth one three-stage compression with water intercooler, and last one three-stage compression with flash intercoolers. So in this video we are going to see the overview of this compound VCR systems. So first one we are taking the two-stage compression with liquid intercooler. In this arrangement of two-stage compression with liquid intercooler, we can see the liquid intercooler is placed between the two compressor, that is high pressure compressor and low pressure compressor. So first of all, the horizontal pressure line representing the evaporator pressure, that is we can see in this pH chart here, this line 6 to 1 that indicates the evaporator pressure. Then above line 545 that indicates the compressor pressure, and in between 2 to 3 is intermediate pressure. So the saturated vapor refrigerant that enters at 0.1 into the compressor, that is here low pressure compressor. Isentropically it is compressed and delivered to the refrigerant in superheated state, that is here. Now it is intercooled by intercooler up to 4.3, that is saturated vapor, and that saturated vapor further goes to the higher pressure compressor, and that again compressed and delivered at superheated state, and that superheated refrigerant then passed through the condenser. So here at 4 point the superheated state refrigerant is available after second compression, and this is the condensation process. And that condensate is now transferred through the expansion valve, which again passing from the liquid intercooler, and then only the saturated liquid it is transferred through the second expansion valve, and then it again transferred to the evaporator, and then it is passed from the low pressure compressor and higher pressure compressor, and that cycle continues. So here the M1 is the mass of refrigerant that is passing through the evaporator, and M2 is the mass of the refrigerant that is passing through the condenser. So M3, the high pressure compressor in given system, will compress the mass of refrigerant from the low pressure compressor, that is M1, and the mass of liquid evaporate in the liquid intercooler during cooling or desuperheating of superheated vapor that is coming from the low pressure compressor, is M3. So M3 is the mass of liquid evaporated inside the intercooler here, that is M3. So we can say that M3 is equal to M2 minus M1. So here we can see the cycle 1 to 2, that is low pressure compressor, 2 to 3, that is intercooler, and in between there is also vapor, 3 to 4, that is mix up with the here liquid that is coming from the first expansion valve here, and only liquid transfer to the second expansion valve, 3 to 4 higher pressure compression, 4 to 5 condensation, and 6 to 1 is evaporation. So as I have said, M1 is the mass of refrigerant passing through evaporator, M2 is passing from condenser. So applying heat balance at liquid intercooler, we are having the mass of M2 that is entering to the intercooler, and mass of M1 that is exiting the intercooler in liquid state, and mass of M1 that is entering in vapor state, and mass M2 that is exiting in vapor state, and in between mass M3 that is evaporated inside the intercooler during the subcooling, or we can say intercooling of the superheated vapor that is coming from the low pressure compressor. So M2 HF5 plus M1 H2 is equal to M1 H6 plus M2 H3. So from that we are getting the equation of M2. So here this is the M2, and from that we are having M3. So refrigerating effect is M1 H1 minus HF5, that is equal to 210 Q, kilojoule per minute. So here we can see that between 6 and 1. Also work done, that is of two compressor, that is M1 H2 minus H1 plus M2 H4 minus H3. Here this one and this one 2. So this is the power, and COP is the ratio of RE divided by W. So it is 210Q divided by P into 60. So this is what about the two-stage VCR system having intercooler in between the two compressors. So the function of intercooler is to cool the vapor which is coming from the low pressure compressor, and that is again transferred to the higher pressure compressor by the liquid that is coming from the first expansion valve and transferring to the second expansion valve. Now next system is two-stage compression with water intercooler and liquid subcooler. So here the change, we can see that instead of single liquid intercooler we are having two different cooler, that is water intercooler in between the two compressor and liquid subcooler in between the condenser and expansion valve. So the saturated vapor refrigerant at the evaporator pressure here at point 1, that is admitted to the compressor. In this compressor, the refrigerant is compressed isentropically from evaporator pressure to water intercooler pressure. Then refrigerant leaving the low pressure compressor at point 2 is in superheated state, which is cooled inside the water intercooler by means of water in order to reduce the degree of superheat and converted into the saturated vapor. So 223, that represents the water intercooling or de-superheating of the refrigerant process. And after that, the refrigerant leaving the water intercooler at point 3 enters to the high pressure compressor, that is isentropically compressed to the condenser pressure at point 4, that is delivered. So 3 to 4 is the, we can see in pH chart, 1 to 2 that is compression, 2 to 3 that is water intercooling, 3 to 4 that is again compression in higher pressure, and 4 to 5 that is condensation. So here 4 to 5 is condensation process, and after 5 there is a liquid subcooler which subcools the liquid up to 0.6, and then it is passed from the expansion valve. So here we can see that in pH chart, the 5 to 6 is the liquid subcooling, and then 6 to 7 that is expansion, and 7 to 1 that is evaporation. So here at point 3, the refrigerant which is delivered to the compressor, higher pressure compressor, is not fully saturated vapor. It has some degree of superheat. So in previous case we have seen that the refrigerant which is at 3 point after exiting the intercooler, that is at saturated vapor line, but in this case it is in superheated state. So here the mass is single, so M is 210Q divided by H1 minus HF6 kg per minute. W, work done, that is of 2 compressor, that is M H2 minus H1 plus M H4 minus H3, and refrigerating effect is M H1 minus HF 5. COP remains same, 210Q by P into 60, or we can say RE divided by W. So COP is same for all the systems, and work done is also same for all the systems. Now next system is two-stage compressor with water intercooler, liquid subcooler and liquid flush chamber. Here in this system there are three major components, that is water intercooler, liquid subcooler and flush chamber. The function of water intercooler is to reduce the degree of superheat of refrigerant which is coming out from the low pressure compressor. The function of liquid subcooler is to subcool the liquid refrigerant which is coming out from the condenser, and the function of flush chamber is to remove the flash of vapor that is generated during the expansion process in first expansion valve. So here we can also see on pH chart, that is 1 to 2 is the low pressure compression, 4 to 5 is the higher pressure compression, 5 to 6 is condensation, 6 to 7 is the subcooling, and 11 to 1 is evaporation. Here we can see that the suction of the vapor is started from the point 4. It is due to 2 to 3 is the water intercooling, and 4 point is the after the mixing of vapor, or we can say flash, which is generated in the flash chamber with the vapor coming from the water intercooler. So the temperature will reduce slightly. So from 4 to 5, that is higher pressure compression, so that we can have more degree of superheat. Then 6 to 7 is the liquid subcooling, and 7 to 8 is expansion. Here we can see that 8 to 10 is the process which is occur inside the flash chamber, and 8 to 9 to 4, that is the removal of flash and mix up with the vapor which is coming from the low pressure side. And here in second expansion valve E2, only saturated liquid is transferred. So 10 to 11 is the second expansion. The liquid refrigerant that is entering inside the evaporator has some amount of vapor available inside the mixture. Now the M1 is the mass that is transferred from the evaporator, M2 is the mass which is transferred from the condenser, and M3 is the mass of flash vapor that is extracted from the flash chamber. So M1 is equal to M2 minus M3, and as we know, if Q is the turn of refrigeration, M1 is equal to 210 Q divided by H1 minus HF10 kg per minute. By taking the heat balance at the flash chamber, we are having M2H8 is equal to M3H9 plus M1 HF9, heat balance plus mass balance. Also the M2H4 is equal to M3H9 plus M1H3 here. At this junction. So this is where the flash chamber and this is where the mixture occurs. So from that we are having M3 is equal to this equation. So if we see, then RE is equal to M H1 minus H11, or we can say 210 Q kilojoule per minute. Here two work done is there, as we have discussed previously that for two-stage compression systems work done is remain same, that is the addition of two compressor work done. So W is equal to WL plus WH, where WL is equal to M1 H2 minus H1 and WH is equal to M2 H5 minus H4. This is for low pressure compressor and this is for high pressure compressor. So COP is equal to RE by W, or we can say 210 Q by P into 60. So now next is two-stage compression with water intercooler, liquid subcooler and liquid plus intercooler. Here some of the difference are there. In previous system we have seen that the water intercooler is directly connected with the flash that is removed from the flash chamber, but in this system the water intercooler, the refrigerant which is coming out from the low pressure compressor, that is first inserted into the flash chamber and then exiting in terms of vapor from the flash chamber. So here what happens, it is mixed at 3 point. The vapor which is coming out from the water intercooler and flash which is coming out from the flash chamber are mixed at this point and then forwarded to the high pressure compressor. But in this case the vapor refrigerant coming out from the water intercooler is first inserted into the flash chamber and then exiting from the flash chamber in terms of vapor. Remaining whole system is same. The function of water intercooler and liquid subcooler is same, but the change in the pH diagram, that instead of 4 point in previous system that is available here, so there are some degree of superheat before entering to the higher pressure compressor. Here the 4 point available is at saturated vapor line, so only and only saturated vapor is forwarded inside the higher pressure compressor, so the degree of superheat is somewhat less. So the compressor need to be handle less volume of the vapor. This remaining system is same as the previous one, so M1 remains same, that is 210 Q H1 divided by H1 minus HF10 kg per minute. The difference is the heat balance, that is heat taken by the flash intercooler is equal to heat given by the flash intercooler. So M2H8 plus M1H3, that is the entering mass, M2H4 plus M1HF9, that is the exiting mass. So from that we are having M2 10 kg per minute and RE is equal to M H1 minus HF9 is equal to 210 Q kilojoule per minute. M, or we can say M1. So same, ultimately COP is equal to refrigerating effect by W. Now these are the major two-stage compression system. Now moving forward to the three-stage compression. So here the first system is three-stage compression with water intercoolers. So comparing to the two-stage compression, here three compressors are there, that is low pressure compressor, intermediate compressor and higher pressure compressor. So in between two there are one water intercooler to reduce the degree of superheat of the refrigerant. So remaining system is simple. So on pH chart if we see that 1 to 2 is the low pressure compression, 2 to 3 is the water intercooler, 3 to 4 is intermediate compression, 4 to 5 is again water intercooler and 5 to 6 is higher pressure compressor. So each and every time we can see that the degree of superheat is reduced. Instead of today's point we are having the 6 point. So the total mass is same for whole system. So m is equal to 210 q divided by h1 minus hf7 kg per minute. Here instead of 2 work, here there are 3 works, that is low pressure compressor, intermediate and higher pressure compressor. So the work done is equal to WL plus WI plus WH, and refrigerating effect is same, that is 210 q kilojoule per minute. So COP is equal to RE by W, or we can say 210 q by P into 60. So here the major difference is that instead of 2 compressor, here there are 3 compressor. So the pressure, condenser pressure, can obtain higher compared to 2-stage compressor. These systems are required where high pressure of condenser is required. Okay, next system for this 3-stage compression is with flash chambers. So here 2 flash chambers are there, F1 and F2, and there are 3 expansion valves. So first, the vapor coming out from the evaporator compressed inside the low pressure compressor. In intermediate compressor, the flash which is removed from the first flash chamber is compressed and mixed with the vapor which is coming from the low pressure compressor. In higher pressure compressor, only the flash which is removed from the second flash chamber is compressed, and that is mixed with the previous vapors and then transfer from the condenser. So the liquid refrigerant which is coming out from the condenser is first expanded and transferred to the flash chamber. From some amount of flash generated, that flash is transferred to high compression, and only liquid is transferred forwarded. In F1, again the flash which is generated in second expansion valve is removed and transferred to the intermediate pressure compressor, and only liquid is transferred to the expansion valve. So if we can see on pH chart, the difference between with water intercooler and this flash chamber system is the 2 point here. So maximum work is done by the low pressure compressor. So each and every compressor has to generate the pressure of condenser pressure. So first compressor has to compress from evaporator pressure to condenser pressure. Intermediate pressure compressor has to compress from the intermediate pressure to condenser pressure, and higher pressure compressor has to also compress from intermediate to condenser pressure. So the compression ratio for the first compressor is very high. But if we can see that the each and every time the liquid refrigerant that is forwarding towards the evaporator is in saturated liquid state. So each and every time the flash is removed and only is liquid that is transferred to the evaporator. So the refrigerating effect generated, that is higher compared to previous system. So here there are 3 mass, that M1, M2 and M3. So M1 is the mass that is transferred from the evaporator. If we consider M is the total mass of the refrigerant leaving the condenser at the point 7 here. Then from M, the M5 mass of flash is generated and that is transferred to higher pressure compressor, and M9 mass of liquid refrigerant is transferred forwarded to E2 expansion valve. And in first flash chamber, the mass M3 of flash is generated and mass of M11 is the liquid refrigerant that is transferred to E1 expansion valve. So the mass of refrigerant passing through the evaporator or low pressure compressor is M1, or we can also say that it is equal to M11. So this is why, because in analysis of the system it is important to calculate each and every mass. So M1 is equal to M11, that is M into 1 minus x8 into 1 minus x10 kg per minute, and M1 is equal to 210 Q divided by H1 minus HF11 kg per minute. So total M will be 210 Q divided by 1 minus x8 into 1 minus x10 into H1 minus HF11 kg per minute. Here 1 minus x8 and 1 minus x10 is the dryness fraction of the refrigerant, that is here. We can see that x8 is the dryness fraction at end point and x10 is the dryness fraction of the liquid refrigerant which is coming out from the expansion valve having the flash. So low pressure compressor has M1 H2 minus H1, intermediate has M3 H4 minus H3, and higher pressure has M5 H6 minus H5. So if we consider each and every mass, then M5 will be equal to M into x8 kg per minute, then M3 is equal to M minus M5, M into x10 M5 into x10. So M3 will be here the flash which is generated in flash chamber. So M9 mass M9 is forwarded, so M3 is equal to M9 into x10, and that is equal to M into 1 minus x8 into x10, but M9 is equal to M minus M5, so M minus mx8, or it is equal to M into 1 minus x8. So that is how M1 or M11 is calculated. And as we know, COP is RE by W, and RE is equal to 210 Q kg per minute. Next, 3-stage compression with flash intercoolers. So instead of flash chamber, here we are having flash intercoolers. Two flash intercoolers are available and 3 expansion valve. So same, But in this case, what happens, the whatever is refrigerant coming out from the every compressor is firstly transferred to the flash intercooler. So only saturated vapor is transferred to the next compressor. So here if we see that the first liquid refrigerant coming out from the condenser, that is somewhat refrigerant is transferred from the expansion valve and remaining refrigerant is transferred to the next portion of the system. So the expanded refrigerant is transferred to the flash intercooler where the vapor and liquid are merged, and forwarded liquid refrigerant, that is transfer again somewhat is transferred from the expansion valve and remaining is transferred through the evaporator. So the vapor coming from the low pressure compressor is mixed with the expanded refrigerant inside the flash intercooler F1, where the vapor is transferred to the intermediate compressor and then it is mixed with the expanded refrigerant in E3 and mixed into the flash intercooler. So if we compare the previous and this system with the pH chart, here we can see that every compressor has lesser work or compression will be less. So compression ratio is less, so compressor size is also less. So every compressor has to work less compared to previous system, but the major difference is there, the point 10, or we can say the point where refrigerant enters into the evaporator, it has major dryness fraction. So the amount of vapor is higher compared to the previous system. Here the 12 point is the point where the refrigerant entering to the evaporator, and here it is 10. So we can see that much amount of dryness is available inside the system. So if we compare or take heat balance of the system, then heat taken by flash intercooler F1 is heat given by the flash intercooler F1. So from that we are having M2 is equal to M1 into H2 minus H3 divided by 3 minus H7 kg per minute, and M5 is equal to M3 plus M4. And from the flash intercooler F2, here M2 in terms of M3. So M1 is the mass that is transferred from the first intercooler and evaporator, here that is M1. So M1 mass is entering inside the first flash intercooler. M2 is the mass that is liquid refrigerant which is transferred from the E2 expansion valve, and M3 is the total mass that is mix up of M1 and M2. So we can say that M3 is equal to M1 plus M2. Now that M3 is entering to the second flash intercooler, and M2, the same amount that is extracted here at E2, the same amount of mass is extracted also from the here at E3. So M3 is entering, M2 is entering, and M5 is exiting. So M5 is again M3 plus M2. So M5 is the mass of refrigerant that is passing through the higher pressure compressor, or we can say condenser, and M3 is the mass of refrigerant that is passing from the intermediate compressor. So from that In low pressure compression, only mass M1 is transferred, intermediate compressor M3 is transferred, and higher pressure mass of M5 transferred. So remaining system is same, that is W is equal to summation of 3 work, refrigerating effect, that is 210Q, and COP is RE by W. So next system of 3-stage compression is with multiple expansion valve and flash intercoolers. So in previous system we have seen that the individual expansion valve and flash intercooler, but here there is multiple expansion valve and flash intercooler. So the liquid refrigerant coming out from the condenser is expanded and then transferred to the flash intercooler, where flash is removed and only liquid is forwarded toward the next expansion valve, and the vapor from the intermediate compressor is coming, that is also mixed with the flash. Same system occurs in flash intercooler first, that is the vapor refrigerant coming out from the low pressure compressor is transferred to the flash intercooler, which is mixed up with the liquid refrigerant coming from the E2, and flash and vapor are transferred to intermediate compressor. So if we see on pH chart, the negative point, that is here we are getting the point 10 in previous system here. So degree of super dryness fraction, that will be reduced in here. So we are having 0.12 here. So the refrigerating effect which is generated in this system is more compared to individual expansion valves. So here same, the total mass of M1, that is transferred from the evaporator, or we can say it is equal to M11. Then M3 is transferred from the intermediate compressor, and M5 is transferred from the higher pressure compressor. And each and every point of flash intercooler, we are having some amount of dryness of the refrigerant, that is X8 and X10. So from that we are having different equations of M2, M3. So for low pressure compressor, M1 is there, intermediate pressure M3 is there, and higher pressure M5 is there. So this is the major difference between previous one and this one. Power, refrigerating effect, and COP remains same as the previous one. Only the difference is that the refrigerating effect is higher compared to previous system. So this is the compound system of the VCR cycle. So in this video we have seen the different kind of 2-stage compression and 3-stage compression.